Welcome back to AI Chronicles. Today, I'm thrilled to have Frank from Voyage AI joining us. And before we dive in, a huge congratulations to you and the entire Voyage AI team on the recent acquisition by MongoDB.
Thank you.
It's always exciting to see innovative AI companies making big moves. And today, we will explore one of the hottest topics in AI, multimodal AI. We're talking about AI that doesn't just see or hear, but truly understands across different data types. Now, but before we get into the technical deep dive, let's start with something fun. Frank, if you could have one AI superpower in real life, what would it be and why?
Wow. Okay, that is a loaded question. One AI superpower in real life, I think, and I'm gonna go a little bit broader here, maybe a little bit more generic and related to the models directly. I would love to know how the models know so much. I don't know if that's necessarily what you would consider an AI superpower, but more of like a superpower of being able to understand what's going on under the hood. And I think for a lot of modern AI, for a lot of neural network based models out there, there's still a lot of explainability
Okay.
that research that I think still needs to be done. So I would really love to just like be able to peek under the hood, see exactly what's going on underneath all these large language models and models more broadly.
Love that. Love that. All right, let's jump in. To start, can you briefly explain what multimodal AI is and why it is becoming so important in the AI landscape?
For sure. I think multimodal AI, I think in your introduction you said it perfectly, right? So it is AI that really understands not just text, right? You don't interact it purely through a chat interface or through, by giving it documents or by asking it questions. You can interact with it through voice. You can give it images, video, and potentially other forms of unstructured data as well. And there's many different types of unstructured data out there. A lot of my talks in the past, year or two, I've talked about many of the different types of unstructured data. There's time series data, a variety of forms of graphs, and basically multimodal AI is just the capability for these models to understand many different forms of data, and ideally with the same neural network as well, with the same underlying model.
Mhm. Nice. And do you see any, like, I don't know, just challenges, any specific type of unstructured? Do you see more, like, people facing more challenges or issues?
I think a lot of it just comes down to the data that you have. And if you look at 4.0 or if you look at some Llama 3.3, these are great models at their core, but they support really just visual, audio, and text data because that kind of data is the most plentiful. I
Mhm.
think if there were other forms of data, or if we could, create other forms of synthetic data that could mimic a lot of what we actually find in the real world, like let's say some real, tons of time series data, or if we could mimic tons of different types of graphs or molecular structures or anything like that, right? And we found a way to, I guess, tokenize these different forms of data and also feed them into a neural network in a way that it understands a lot of the context that surrounds it. Then I think potentially we could have, these sort of super multimodal kinds of models, right? I think a lot of the limitations that we see today are really due to data and really the quantity and the quality of that data as well. So that's probably why I think in the short term, maybe even in the medium term, we're not really going to see that much multimodal. We're not going to see that much activity in multimodal models beyond just images, video, audio, and natural language. But I do hope that will change at a certain point, and I think it will.
Yeah, I feel like we are at least heading towards that shift, I would say, because we have so much data that's unstructured and people are building models that support the multimodality. So, hoping to see more and more of that. Now, could you share some real world use cases either you have worked on personally or at Voyage that leverage these multimodal techniques?
Yeah, I think I'll talk about Voyage a little bit more specifically. And we released, towards the end of last year, we released a model called Voyage Multimodal 3. So it is part of our 3 series of multimodal models. And it's a very unique multimodal embedding model. So these typical embedding models or typical multimodal models are clip or clip-like, which means
Right.
that they have separate towers or separate trunks, whatever you want to call them, basically separate models for each of the different modalities. You have a model that embeds the images, and you also have a different model that embeds text. And the idea is that these two, both all of these different trunks that a clip-like model might have are trained to minimize the loss or minimize the error between those embeddings. But there's only, with clip-like models, there's only so far that you can take them. They end up being, there's a lot of downsides. I'll just name a couple, maybe two or three here. The first is that clip-like models, you can only accept a single type of data. So you can't accept
Right.
interleaved images and text. I think the other thing is that it can only accept one image at a time. So if, let's say,
Wow.
I had a PDF which was 3 pages or 5 pages, and I wanted to embed all of that, right? There's no way for me to give all of these subsequent pages back to back. And one last thing I'll say, which dives a little bit deeper into some of the technical issues surrounding clip-like models, is what's called the modality gap. I won't dive too deep into exactly why this appears, but the modality gap is essentially the idea that the concept that text, if I have text as an input to these clip-like models, it will be much, much closer. The embeddings generated by clip will be much, much closer to irrelevant text than relevant images, if that makes sense. So there's always a bias in the modality for clip-like models. And for Voyage Multimodal 3 specifically, this is a sort of it's based off of modern vision language models. So you actually have the capability, it pretty much fixes all of those downsides that I talked about earlier. Not only do you have the capability to embed many images, but you can do interleaved images and text as well. And there's also no modality gap problem because everything is embedded with a single model with the same transformer encoder. And that has led us to a lot of really super interesting applications. I want to say, probably the one that I like the most is we have a company that has actually built this agentic retrieval framework across both image and text data, and it's actually specifically financial image and text data. And basically, what happens is if they, if they get a query, what happens is, this agent will try to retrieve the most relevant data, and it will continually do that kind of retrieval in a multimodal fashion. So in some cases, it will be retrieving images of PDFs. In some cases, it could be even retrieving some photographs. In other cases, it'll be retrieving raw text, and it'll continually retrieve data from the database until it determines it has the information it needs to answer a particular question or to analyze, let's say, a stock or to analyze a company. So it's a super interesting use case that I found leveraging multimodal AI. And I think a lot of it really boils down to, and maybe this is a topic for another day, but a lot of it boils down to, more of the understanding of documents and more of the understanding of different types of data being baked into the model, rather than saying, hey, I need to put all this scaffolding around my RAG or around my retrieval system in order for it to work in the way that I want it
Wow. Okay, that was a lot of information. But
to.
two questions.
What?
One, I'm curious, especially about the multimodality gap. That's the term like I haven't thought about or come across. Now, you mentioned something about bias. I'm
Yep.
curious, where is this bias coming from? Like, is it from the image data or whatever like
Good
unstructured
question.
data, or is it like, where's the origin?
The origin of this bias comes from the fact that there are two different models to begin with. So if I were to sort of try to distill it, you can think of these two models as already occupying two different areas in this high dimensional space. So even though, right, they both output, let's say, 512 or 768 or 1024 dimensional vectors, the distribution of those vectors in this high dimensional space is wildly different between these two models. And when I train a clip-like model, right, a model that is not, one of the more traditional multimodal models, I'm simply trying to get, you can think of it as trying to get these really high-dimensional spaces to become closer or as close as possible, but they never really truly overlap with each other. Think of it that way. And that's really where this bias, this modality gap or modality bias comes from. Simply the fact that there are two different models with two different unique forms of initialization, and really two different modalities as well. So the way that the data is fed to these models is also a little bit different. And you really, that's why you really want an embedding model that is inspired by VLMs like Llama 3.3, for example, or GPT 4.0, simply because now these models have the capability to put everything through the same
Hmm.
set of weights.
Got it. Okay, that makes a lot of sense. Now, my second question is when you mentioned about how these models will keep retrieving repeatedly to find the relevant answer, what are the side effects of that, for lack of a better term?
Yeah, I think one of the side effects is a longer runtime for
Longer
sure.
runtime, yeah.
Longer runtime, but it really goes into the whole. I think it's always a trade off, right? And the rage these days is reasoning models.
Mm,
Everybody's building reasoning. DeepSeek is building them. You know,
yeah.
OpenAI it's the OG reasoning model, O1, O3, and in a way, agentic or multi-step retrieval is the same thing. We are starting with some set of data, or maybe a smaller a top K of maybe 10 or 15. And maybe for most use cases, or most prompts, or most questions, that is enough data to answer the question. But oftentimes, for something that requires a little bit more thinking, or something that requires a few more steps, you need to retrieve different types of information, or you need to retrieve different domains of information as well. I'll give you an example. If I want to answer the question, if I'm taking a look at a company A's filing for IPO, and I want to calculate, let's say, I want to calculate the total revenue over the past 4 quarters, and perhaps that is located in many different locations throughout that document. Maybe I have to retrieve multiple times in that document, first in Q1, then in Q2, Q3, Q4, in order to be able to get that information. That's really why I think multi-step retrieval, or in this case, I think the buzzword to use is agentic retrieval,
Mm,
can be so useful, and why it provides a lot of positive value for a lot of businesses and other organizations out there as well.
got it. Got it. Okay, actually, now that leads to my next question, and I think you probably covered a little bit, but just in case. Now, what are some of the major technical challenges you face when building and deploying these multimodal models,
Yeah.
such as managing different data types and ensuring model performance?
Yeah, great question. Great question. I'll probably start with, I think the biggest one is simply managing all these different forms of data, managing all these different data types, as you just mentioned. That always ends up being one of the biggest challenges, not because it is a hard problem in and of itself necessarily, but it's a lot of plumbing, if you think about it,
Mm,
right? If I have data in I have data in many different places. Sometimes I have data that's stored on S3, sometimes it's in Google Drive, and even if it's in these different kinds of places, it's also in different formats as well.
mm,
It could be a Word document, it could be a PDF, it could be a PowerPoint, it could be raw text, maybe it could be a YAML file or a script, right? And I have to find ways to, if I'm an organization, I have all these different sources of data. I have to find ways to transform them into the kind of inputs that can be accepted by my multimodal model. So if it is a multimodal large language model or a multimodal embedding model like what we provide, it's all the same deal, right? You need to be able to transform it, and you need to be able to prompt it in the right way so that the model is actually capable of understanding all these kinds of data. It could be as easy as turning PDFs into screenshots, or it could be something that's much more complex than that as well. Maybe I want to take a combination of Word documents and some images, and do some sort of fancy, agglomeration or some transformation on top of that, and then feed that data. Into run inference across those models in these, or excuse me, run inference across this data using my models. So I think a lot of it really boils down to the management of data. A lot of it boils down to a plumbing that's associated with it. This is a term the term I like to use here is unstructured data ETL, with emphasis on the T rather than on the E. So
mm,
emphasis on the transformation rather than on the
mm.
extraction.
Right.
Uh, but I would say that's one of the biggest challenges today. towards in and around multimodal AI adoption.
When you say plumbing, is it what you mean by unstructured ETL?
Exactly. Yeah,
Okay.
exactly. So just as you would, if you're building out like a network of, it's almost as if you're building out a network of pipes, and these pipes, the idea is that in the end they should all connect to, the set of multimodal models that I have, so that I can get some intelligence out of them.
Got it. Okay. Okay. Going towards a little bit more technical uh, aspect of this topic, how do you approach creating shared embedding spaces that effectively integrate different data modalities, whether it's text, images, audio, whichever, into a single representation?
That is an excellent question. And what I will probably do for this question is simply to use only two modalities, text and images, but this
Okay.
also extends to audio and to a certain extent to video as well. I talked about this, I briefly touched upon this a little bit earlier, but what you want, and I come from the perspective of embeddings and embedding models and RAG retrieval, all that kind of stuff. But for embedding models in particular, what you want is you want your embeddings, when you talk about multimodality, you want your embeddings to represent the image and not the modality. Or excuse me, you want the embeddings to represent the data and not the modality. So if I have a screenshot of some text and I have that raw text as well, let's say in a string, a Python string, or let's say, just represented as a series of bytes, I want those two embeddings to be very, very close to each other. And that is I think the only way to do that is by putting all of that data through a single backbone or through a single model. And that's simply not what clip-like models do. In my opinion, I think the key to building these powerful multimodal representations or these powerful multimodal embeddings is to take a page out of the book of modern VLMs, modern vision language models, and to patchify the images or to tokenize the images in a way that they can actually be projected directly into these encoders, into these transformer encoders, so that you get a consistent representation at the end. This is not necessarily something that is easy to do. It does require a lot of data. It requires a lot of work from that perspective. There's a lot of tricks that are needed to train these models properly as well. But it definitely results in the best embeddings, and it definitely results in the best outcomes as well.
Now, okay, you mentioned some challenges with this single representation. Do you see any trade-offs that you might have encountered in building and deploying these multimodal embeddings?
Great question. I think for multimodal embeddings, right, if I have screenshots of text, I think one mistake at least that sometimes I see is that a lot of people will come and use our multimodal models and put screenshots of PDFs into them, and they say, hey, the performance is not as good as if I had just parsed out the text. And I think that is to be expected. Um, at the end of the day, if you have just a single modality of data, if you have just text, it is better to use a pure text embedding model rather than a multimodal embedding model. So, and if I were to dig a little bit deeper into that, right? If I have documents that are PDFs, right, and I have, and I just give all those PDFs. PDFs are full of text. They could be talking about, it could be in the finance domain or in the legal domain, or anything, right? And I give that text to my multimodal embedding model. The output embeddings are always going to be a little bit worse in terms of accuracy than if I just simply did perfect parsing of that PDF and gave the results to a text embedding model, a pure text embedding model like Voyage 3 or Voyage 3 Large. I think currently that is perhaps a side effect of maybe the multimodal embedding model. Perhaps there's a variety of different reasons for that, but I would say that is maybe the biggest sort of barrier to deploying a lot of these multimodal embeddings. That if you have a really, really good parser, currently the pure text embeddings are still better than the multimodal embeddings. Now, if you have if you're trying to embed photos, right, stuff that doesn't have text in it, or if you're trying to embed like GIFs or they're like slides that have a lot of arrows, diagrams, or figures, then I would say, hey, then that's when it really makes sense to use a multimodal embedding model. Perhaps that's your only choice, right? A multimodal embedding model like Voyage Multimodal 3. But if your data is still primarily text, right, and if your PDFs are also primarily text, or your Word documents are primarily text, they don't have many graphics or images into them, it is still better to use a good parser plus a pure text embedding model. I do think that will change in the future.
Yeah.
I do think multimodal models will get more and more powerful, just as these multimodal large language models today are super powerful. I think there's a lot of companies that are doing OCR using
Yeah.
these multimodal large language models. I think multimodal embedding models will also go in the same direction. They will also become more and more powerful in terms of understanding the text within those documents.
Got it. While you were telling me, I thought about, I have a question. So you said that we still have like text emitting models are much stronger compared to others. Why do you think there's that gap? Is it because we don't have the right models to embed based on the data? Because I'm sure there's no shortage of image, audio, video data
Yep,
right
yep,
now.
yep, yep. Yeah, that is an interesting question. I think at the end of the day is that when you have a multimodal embedding model, all of a sudden the I'm not sure what the right if I'm not sure if I'm using the right phrase here, but the input space has become much larger. So especially if you can accept interleave text and images, now all of a sudden there's many different ways for you to give a document or give some input to that multimodal embedding model. So for example, right, I could have maybe if I have a Word document with just a figure and then some text underneath it, a caption, right? I could screenshot all of that and give it to the
Mm.
multimodal embedding model. I could take just the figure as an image and then take the caption as text and give it to the multimodal embedding model. And if we have all these, I think, perhaps we can also take that input figure or take that figure at the top, transcribe it, right? Describe what's going on inside of that figure and then attach it to the caption. So now all of a sudden we have three different ways of being able to represent the same document, the same image, the same information, right? One is pure text, one is a pure image, and one is a combination of images and text. And all of a sudden we have to represent all of those. The model has to have a much higher representational capacity and be able to know that all of those different pieces of information correspond to actually the same thing. So I think it's simply because one is the more modalities you add, the higher or the larger the input space becomes. The more ways that a multimodal embedding, there's more ways for things to go wrong as well. And also you just need like a huge wealth of data, right? And ideally a huge wealth of interleave data. I think that's what makes multimodal embedding models a little bit harder. Why it's easier to just focus on pure text, and why currently, at least most of the reasoning models cannot reason across images and definitely
Mm.
cannot reason across audio either.
I bet. That's interesting. Uh, okay, so this comes to like my next question is of my favorite topic, but it's ethics and
Yep.
privacy
Yep.
and whatnot.
All right.
Now, as we fuse more data types, images, audio, text, video, etc., how do we ensure we respect user privacy and maintain ethical standards? Like, do you
Yep.
see any big risk, or if you are aware of what safeguards should be in place, if you can share that with us.
Yeah, absolutely. And I think as we most of the data that is out there today is unstructured. I would say probably most data that is being generated is maybe in the form of video data, or that's the largest that's being generated. And embedded inside of video data, there's a lot of there could be, like, let's say, a lot of PI inside of there. There's obviously, if it's Zoom calls, or if it's Google Meet calls, or if it's panels or conferences, there's obviously a lot of there's different faces in there, and I think there's just a lot of the more modalities you have, I think the more that privacy becomes a bit of a concern.
Exactly.
I think, yeah, I think honestly, like I wish I could give you a better answer to your question here. I don't know of a whole lot of great ways of being able to know, of being able to understand, is there some sensitive information in this unstructured data? And
Mhm.
the reason is just simply because there are so many different forms of it. And if the data is unstructured, it's hard for companies, it's hard for organizations, hard for individuals to build rules around that data to know if there is something going on, or if there
Mhm.
is potentially some form, some sort of some privacy issues, or if there are if there's anything that we need to watch out for. I
Got it.
think perhaps one of the things that does excite me moving forward is simply the fact that there is a lot more, there are some companies that still continue to pay attention to the safety of their embedding models. So Anthropic, I think, is doing a great job of this. For us, it's a little bit different because since we generate embeddings, it's impossible to take an embedding and go back to the original representation, especially if it's a multimodal,
Oh, yeah.
if it's an embedding across multimodal data. It's just really, really hard.
Extra
So
layer
for
of
us,
challenge.
exactly, right? So for us, it's not as much of an issue. We're also not a generative model, so we don't have to worry that much about regurgitating any input data or training data. And yeah, it's a bit less of an issue for us, but it is really exciting for me at least to see that there are companies out there that still put a huge premium on safety and to make sure that their models are really aligned with our values. And again, privacy, security, safety being one of them, being some of them.
Fair point. So, looking ahead, what are you most excited about in this
Ooh,
multimodal AI space? Like any emerging technologies or
ooh,
research
yeah.
directions?
Great question. I would love to see. You know what? I hate to jump on the bandwagon here, but I would love to see multimodal reasoners. I would love to
Reasoners.
see, yeah, I would love to see large language models, right? So I'd love to see large language models reason in multimodal ways. So perhaps, there's one really interesting. I think there was an interesting post I saw. I forget what model it was. I don't remember if it was O1 or O3, but there was a reasoning model, a reasoning LLM, and halfway through it just switched to using Chinese, to reasoning in Chinese, and then it switched back to reasoning in English. I think after a period of time, which I found very interesting. I found that quite strange. But also at the same time, I think it poses some interesting opportunities out there in that I think it just goes to show that there are different ways of being able to get a model to do reasoning. And perhaps, maybe, because we live in a multimodal world, right? We have all these different senses, and each sense is you could think of it as a different modality, and we reason across these different senses as humans as well. Maybe moving forward, if we can build multimodal reasoners, that is one step closer to having actual, let's say, super intelligent robots that can operate in the real world, that can build on top of the knowledge that they already have, especially if they use some form of retrieval, agentic retrieval or anything like that. They have a knowledge bank, and or maybe they use embeddings in a vector database internally. But I'm getting a little ahead of myself here. But if you really think about it, if you can reason in all these different modalities, if you can reason through, let's say, both text as well as audio, you have a chain of thought that also involves, let's say, images, or let's say some form of visual data. I think that could be super interesting. I don't know how plausible or feasible that is. I think that's
Yeah.
a question that's much, much way advanced, I think, compared to what I have knowledge for. But I do think that that would be super cool, and I do think that it's something that I look forward to.
And that's pretty interesting. Thanks for bringing that up. And it's not just like multimodal reasoning, but also in integrating multilingual. Like you just gave the example how it suddenly switched to Chinese reasoning.
Exactly.
It's like how I switched to from in English
Yeah.
to Hindi
Right.
talking to
Yeah. Yeah.
people.
Yeah. Yeah. Like sometimes when we count, we might count in a different
Yeah,
language, or I think it's quite interesting, and I think there's the possibilities really are endless.
awesome. Okay, well, that's a wrap for this episode. Huge thank you, Frank, for breaking down the fascinating world of multimodal AI and sharing your insights. What's next for this space? And it's clear that the nature of AI isn't just about text or images in isolation. It's about seamless integration across modalities to create smarter and more intuitive systems. Well, if you enjoyed this conversation, don't forget to subscribe and share your thoughts. Until next time, stay curious and keep exploring the world of AI. Thank you.